Hi, good morning, and good morning all of you here. Good morning all of you home. This is the first talk at stage 2. My name is Martijn, I'm your host at this stage. Next to me is Ramandeep. He's going to talk about exception handling in Kotlin. I wish you all a good talk and enjoy it, and good luck to you.
Thank you. Thanks for this amazing introduction, Martijn. Welcome all. Let's start with today's talk for exception handling with Kotlin using Arrow. So first of all, a bit about myself. If I have to describe myself, I would probably go by this quote about setting your goals, making your plans, and I'm all about the dreams. So of course, chasing your dreams. And I cannot describe myself without mentioning that I'm a diehard fan of Novak Djokovic. He's my favorite tennis player. So let's first of all have a sneak peek into today's agenda. First of all, we are going to talk about exceptions and specifically the reason for checked exceptions. Then how to handle error handling in Kotlin. Introduction to Arrow library for error handling. And within Arrow library, we are specifically going to talk about the concept of a monad and using the either data type from Arrow to handle errors. Now we have the either data type, so we need certain functions to compute on that data type, and today specifically we are going to talk about map and Flatmap, and there are of course other functions provided by the documentation for the operations on either. And we are going to sum up today's talk by talking about the design of your exception handling framework. Of course, the prerequisite for today's talk is having the basic knowledge of Kotlin, but of course, if you don't have the basic knowledge, I still think you can take away something from this session. So let's start. So we are all aware what exceptions are. I think we need to talk a bit about Java, and Java, as you know, has the concept of checked and unchecked exceptions. And we all know that checked exceptions are checked at compile time, unchecked exceptions occur at runtime. However, there has been a whole debate between checked versus unchecked exceptions. Luckily today, we are not going to get into that debate. Nevertheless, it's imperative to understand the origin of checked exceptions. So let's have a look. The first question that comes to my mind is, why were checked exceptions introduced at first place? So in order to handle error-prone code such as I/O exceptions that might occur with handling of files or network, and these conditions are basically difficult to debug, and also you might forget to handle these error conditions. So solution was found, and the solution was to introduce checked exceptions, basically from the code from my favorite movie, You Shall Not Pass. So compiler is going to complain at the compile time to handle these exceptions. So now it looks like a good solution for the time being. Our compiler is informing us and taking care of this. However, during course of time, a lot of problems got accumulated with checked exceptions. And one of the problem was, in order to fit into this exception handling API, we were just returning a list of contagious list of exceptions. And personally for me, it looked like you have a lot of cat statements within your code, which looks pretty ugly. Also, with the introduction of lambdas in Java 8, it didn't fit well with the functional programming. It made your lambdas unreadable, and of course, they don't fit well with the higher order functions. So now we know that what led to the origin of checked exceptions. Luckily, Kotlin for us has already made the decision to remove checked exceptions, and Kotlin supports only unchecked exceptions. Now, checked exceptions have been removed. What in turn it means is we now have lost our ability to type check our exception handling code. Now, okay, we have solved one problem, but we have another problem to solve. What can we do in this case? I think we need to have some proper error handling techniques in order to handle the error-prone code, or you're probably going to forget error scenarios or end up in throwing a lot of exceptions in your code, which for me looks like you're bombing your application, and I would like to have more control over my exception handling flow, and I would like to use more proper techniques. So let's have a look what are the techniques that we can use for error handling in Kotlin. So first of all, when I talk about exceptions in Kotlin, we still need to handle exceptions. However, these exceptions should be handled by some top-level framework of your application. So there should be a global that we all use at this point of time as well, a global exception handler within your application which is handling those exceptions. For example, again you have an input-output exception, and the user, for example, fills in an invalid input and you want to basically return an appropriate error message to the user. So that exception should be handled by the top-level framework. Having said that, as a rule of thumb, you should not be catching exceptions in your journal Kotlin code. This is probably what you would do in Java. However, in Kotlin, this is regarded as a code smell. Now, I have said journal Kotlin code. What do I mean when I say journal Kotlin code? I mean your core business domain, wherein your business logic lies. You want to keep your functions pure as possible. You want to have a deterministic output for your functions. So let's focus on the journal Kotlin code. What are the techniques that we can use? Because we don't want to catch exceptions, but we have to handle those error conditions. So one of the techniques is to use null safety within Kotlin. Another one is to create seal class in order to map success and error scenarios. The third one is, of course, to use arrow library to handle error in a functional way. And Kotlin also provides you a result data type that can be used for error handling. Let's go into the first one, that is null error handling using null safety. So herein you see an example wherein we have a string which basically represents an integer, and we are trying to call a toInt function. Now it's very obvious that this function can return a number format exception if the string basically does not represent an integer. So what's the alternative in order to handle this error condition? The alternative is to use Kotlin null safety. So Kotlin provides you functions such as toInt or null. It basically returns you the integer value, or if it's not able to convert, it's going to provide you the null value. And using the Elvis operator, you can basically return the default value. And the default value which is returned from this function can be taken care by the top level framework of your application, and you can choose either to return appropriate error message to your user, or if you don't want to return it, you can also log it in your application. So this looks quite simple, that Kotlin already has certain functions for us that can take care of the null safety. Now the next part is using a seal class. So as I said, that seal class can be used to wrap the success and error scenarios. But what is so special about seal class that we need to use it? It represents restricted hierarchies. So you have more control over your inheritance. So what I mean is, all the direct subclasses of the seal class should be declared in the same package. What is the advantage of that is, at the compile time, all the direct subclasses are known. And this is very powerful when we are using error handling, because at compile time you are aware what are the error types that are being returned, and basically you have no surprises later on in your application. Another important point is, the subclasses from the seal class can have multiple instances, and each can hold basically its own state. Now we all know the advantages of the seal class. Let's have a look into the code and see how we would use it. Let's take this example of a seal class with parseDate. Herein you can see that a seal class is basically an abstract class. It can have abstract functions. We have declared a data class success and failure. Success class holds the correct value, that is the date object in this case. And the failure basically holds the error offset, that's the error scenario for us. Let's have an example. Herein we are trying to parse a string into a date. So in case this string is successfully parsed, you wrap the date object within your parseDate.success, and in case there is a parse exception, you wrap up your error object, which is parseDate.failure, into the error offset inside that. So it's apparently very clear that seal class is more of a wrapper class, so you wrap your success and error scenario in both the cases. Now, how to handle the response from the sealed class? There are multiple ways to do it. I think one of the most popular one is using when expression. The advantage of using sealed class with a when expression is compiler forces you to handle all the scenarios that you have specified. So in our case, for part state, we have specified success and failure. So compiler, when using a when expression, forces you to handle both of them. And generally, when we are using a when expression, we need to specify an else part. And the advantage of again using a sealed class with when is, because we have already handled all the possible scenarios, we don't need to provide the else part using when expression for sealed class. So this was the second technique that we talked about. The third one, it is a major part of my talk today, is Arrow, which is basically a library for functional programming in Kotlin. It basically has 4 modules: core, functional, optics, and meta. Today our focus is on the core part. Why? Because core has data types such as either, validated, and many more extension function itself that can be used for error handling techniques. Let's see first of all what are the basic concepts that we need to understand for error handling in Arrow. First, we are going to touch down upon what a monad is. Secondly, data type either, which is going to be used for error handling. And third, again some functions in order to compute with either, such as map and flatmap, which we are going to go in detail today and see how it works under the hood. Let's touch down upon a monad. So very interestingly, Douglas Crockford has coined this term called monadic curse. He says that when someone learns what monads are and how they work, they basically lose their capability to explain to other people. So let's figure out today if I also have that monadic curse or not. But today we are not going to go into the category theory and the mathematical part of it, but try to explain in more simple way. So let's visualize monad as a box. It's a box, it's a wrapper type for which holds certain value, and on that value you can basically perform chain operations with other function or in fact with other monads, and if anything fails during these chained operations you will find out at the end. And right now most of us are giving me this kind of expression, which is quite understandable because it's more complex than it looks like. Let's try to look at monad in more simple way, in more of an implementation mode. So monad is basically an abstract class. It should, let's say, have 3 properties. The first property is of course that it should be a wrapper type. The second property is it should have a map function, and as you can see the input to the map is another function and the lambda returns type B. And the output from the map function is a monad of type B. It means the output from the map is wrapped up in a certain context, and that context we basically referring to the monad. The third property of a monad is having a flat map. So a flat map is a special kind of a map. Again, same as a map, it takes input as a function. The output of a lambda is wrapped up in the context of a monad, and the output of the flat map, as you see, is similar from the output of the lambda, that is monad of type B. And now we are going to jump into the data type either. The reason why on the previous slides we have talked so much about monad, you will figure out on this slide why we wanted to understand what the concept of a monad is. So either is a data type which is provided by Arrow for error handling, and monadic comprehension is available for either. What I mean is basically all the data types within Arrow have monadic comprehensions, and either can be treated also as a monad. So either is a monad for us. It's a wrapper type which can hold certain value, and you can basically perform chained operation on this monad. It represents a presence of either a left value or a right value. Let's see how either looks like. So either under the hood is a seal class. We already talked about what a seal class is and what are the advantages. So by convention in functional programming, we always use the left side to hold the error part and the right side to hold the correct value. Now, how are we going to use either for error handling? Here is an example. So this example, we are trying to get the account type. The input to this example to this function is a string. Using when expression, we are trying to find if the string is a payment or a savings account. So basically, first two are success scenarios for us, and we want to wrap our success scenario using either. So we use either.write for both payments and saving. And in case it's neither a payment nor a savings account, we want to wrap our error scenario. So we basically wrap our error object, business error in this case is the unknown account type, and wrap it in either.left. Now, important thing to note over here is the return type of the function is either, with application error on the left side and the correct value, which is the account type on the right side. So if you have noticed, it's quite similar to what we did in the seal class. The only difference being the implementation is provided by arrow. So you're basically wrapping your success and error scenarios in the right and the left part of either. Now we talked about how to wrap your success and error scenarios. Now how to perform computations on the output from a function that returns either to us. So we have a lot of functions including map, flatmap, fold, is left, is right, map left, by map, a lot more. However, today we are going to focus more on map and flatmap and see how they work under the hood. So as previously talked about, a map is a function, takes input as another function, the lambda returns type B, it wraps the output of the function into another context, which is a monad of type B. Since we are talking about the either monad, so the monad we are referring today is an either monad. It's difficult at this point of view to wrap your head around how map works, but let's look at map more conceptually and try to understand how it works. So here is an example. We have a map, we have a function that wants to add +3. So the input is a wrapped value which holds 2 as an integer, and some magic happens and you get an output which is again wrapped up in certain context. But what is this magic that's happening under the hood? Let's see. So you have a wrapped value. What a map does is it unwraps the value from the context, applies the function 2 + 3 5, rewraps it back in the context and returns to us. Looks quite simple, right? At this point, let's take an example and see how it operates. So this is in first example. You see we are trying to do certain regex pattern matching with the string. So we are trying to see if the string represents a number or not. If this match is successful, we wrap either.write, we wrap the integer value. If it's not, else part, we mapping the error case, that error, it's not a number. So again, the parse function over here, you can see the return type is either, error on the left side, integer value on the right side. We have another simple function called stringify, basically converts int and calls toString function on it. Now what happens when we perform a map operation on parse which has the return type of either? So as discussed, that map is going to unwrap the value. But another important thing to note over here is map always operates on the right side. It's a right based. So in case right value, that is the integer value, is returned from either, it's going to call stringify function. Output of the stringify function is the string. So up till here we have got the string, which is the output from the function. So as discussed, what a map does, it rewraps it back. So it has wrapped the response back in either with the left side of an error and right side as in string. Now let's make it a little bit complex. Now we have another function called reciprocal, again performing some logic. mapping the left and the right side, success and error scenario. Now, when we call map on the parse function, as you see earlier, it operates on the right side. It checks if the integer value is there. Okay, it calls the reciprocal function. The important thing to note, the reciprocal function also returns an either with the left side error and the right side double. So the output from here is an either, and you know what a map does, it rewraps it back in the context. And now you see that idle got doubly wrapped. Okay, this is a problem. We need something else to solve it. That's where a flat map comes into picture. So let's see what a flat map is. Very similar to, it's a kind of a special kind of a map. So very similar to map, it takes input as a function, the output is wrapped up in a certain context, and the output of the flat map is not rewrapped, it's basically the same output from the function as you see. Since we are talking about monads, so of course we are referring to either data type, so the monad we are referring to is either. Let's again look at it more conceptually. So herein again we have an example where you have input to a flat map as a wrapped value, so which is 3 in this case. So what a flat map does, unwraps that value, calls the function. So in this particular case the function is not even and 3 is not an even number, so the output in this case is going to be nothing or none. But what you see, important thing to note, is the output of the function is wrapped up, and the same output gets returned back from the flat map. Maybe it's difficult to visualize at this point. Let's see the example from map and flat map one-to-one. So this is again the previous example we took, wherein we call parse function, and on parse we try to operate using a map. And when you call a map function and you call a function inside it which also returns an either, we saw it got doubly wrapped. How does it look different when we call a flat map? So again, similar to map, flat map also works on the right side. So it only works if the right side is available. So from the parse function, it gets the output either, unwraps. If there is a right side, it's the right side, calls the reciprocal function. Now the output of the reciprocal function is either left and right. Now since we know that flat map returns the output that is similar to the output of the function, so the output of this complete operation is an either with left side error and double on right side. Basically it does not rewrap it, so it flattens the response for you. And of course there are a lot more other functions that are available. So till now we have discussed in detail about a map and a flat map, and there is also fold function which you can apply in case you want to separately handle your success and error scenarios. You have is left, is right, map left. There are a lot more that we can explore according to your use case. However, I want to sum up my talk today about talking about the design of our exception handling framework. So this is how a typical system looks like nowadays. You have a user or a browser who is calling certain REST service, so which is basically interacting with your controller layer, which is your inbound adapter. And then you have your inside code domain, which is basically where your business logic lies. Most of the cases we are either interacting with a database or some external service. So the idea here is we want to keep the inside core domain as pure as possible. So using techniques such as null safety or writing your own sealed class, or either using either from arrow, and not catching those exceptions inside the domain. But let the top level framework, which is interacting with your external services basically, let's say you have a global exception handler at that top level, take care of those exceptions and convert it into appropriate form for the user, or in case you don't want to inform the user, just log it in your application. So the idea here is to define a boundary between your core business domain and where you want to catch exceptions, which is basically at the top level framework. Having said that, this is not by any rule book. or this is not a hardcore defined boundary. Of course, it depends upon your use cases. It might also depend upon the developers within the team, how they feel about creating that boundary between both the layers. But this is the general idea, to keep your domain pure as possible, the function as pure as possible. So this is how I wanted to conclude my talk. Thank you very much.
Yeah, and there we are. I want to thank you, Ramandeep, for a very nice talk. Maybe there are some quick questions in the audience. I see one over there. I'm going to hop to you.
Hey, thank you for a talk. Basically, I have a question. When we do Flatmap, we recreate exception, and usually when I throw exception from Java, I provide previous exception. Is it possible to contain full stacks of exceptions?
Sorry, I didn't get your question.
So with a Flatmap, if you have exception, you create new one exception. Like in your function, you will create, in example, a new exception.
No, I didn't create it.
Function throws an exception. You have neither, you flatmap on that, and the second function also throws an exception.
Yeah. And I lose first one.
Well, the flatmap won't get executed if the first
Yeah,
one.
because it's write-based. It only operates if your right side is present. But if you want to operate on the error, you have functions such as map left, and then it operates on your left side.
Okay, thank you.
Yeah.
Thank you. Any other questions? Otherwise, I'm going to wrap it off. She is available, I think, later at this venue for your questions. We're going over to stage 1 with Bart Enkelaar with the dangerous side of Kotlin. I think we're back here at 12:35-ish with Peter Dekkers about interactive development in Kotlin. So I want to thank you all for coming. Also in the live stream, thank you for joining us and see you in a bit.